In this video, we will practice factoring a variety of polynomials. Whenever you see that your polynomial has 4 terms, your first guess should be grouping. So grouping is where you pair the first 2 terms and then you will pair the last 2 terms. In each case, we're going to factor out the GCF, the greatest common factor. So I'm looking at the 12 and the 9. Those are both divisible by 3. And then I'm looking at t to the 3rd power and t squared. Between those, t squared is the greatest common factor. So the GCF is 3t squared. Now, if I factor out 3t squared, that's going to leave behind 4t minus 3. And another way you can think about that if you want to is in a way we are dividing by the GCF. So I'm dividing by 3t squared. And I would get 4t minus 3. Let's do the same thing with the right-hand side. Both of these are divisible by 5. So I'm going to bring out plus 5. And then that will leave behind 4t minus 3. See how the parentheses are the same? That's crucial for the grouping method. Because these are the same, the 4t minus 3 itself is a common factor. And just like we factored out 3t squared and 5, now we're going to factor the parentheses out. So in other words, I'm going to take 4t minus 3 and I'm going to pull it to the front. So that's going to leave behind the 3t squared and the plus 5. So that's going to leave behind 3t squared plus 5. Now, as I examine the remaining 2 binomials, neither one of these can be factored any further, so that means this is the answer to number 1. Okay, number 2 is different. This is the difference of 2 squares. 169 is 13 times 13. So we have learned that you can factor the difference of 2 squares by doing, for example, a plus 13 times a minus 13. So that's it. This is just the difference of 2 squares pattern. Now, number 3 is also the difference of 2 squares. If you have a variable and a power, any even power is a perfect square. So I'm going to use that same pattern. If I split this right down the middle, this will be x to the 6th power times x to the 6th power. And this one will be y to the 5th power times y to the 5th power. And we will go plus and minus. And that's it. If somehow these were still even, if this was a 6 and say this was a 4, I would factor further. All right, but there's no more difference of 2 squares, so this is the end. All right. Now, when you see a trinomial, and we're going to factor that, first thing you're going to do is look and see, is there a common factor? There isn't. So then your next guess is, okay, if this factors, it should be a binomial times a binomial. First, look at the 2x squared and factor that. 2x squared only factors one way, 2x times x. Next, skip the middle term for now. At the end, I see this 1. Don't worry about the sign yet. 1 can only factor one way, 1 times 1. Now, there's a variety of ways of doing this, the star method and Lizzie's method, and you can do grouping. But the way I do it is I know that the inner plus the outer must equal the middle. Inner, right here, I have 1x. Outer, if I multiply these, I have 2x. Together, this has to give you the middle, which is negative 1x. You can make the signs be whatever you want. If I want a negative 1 result, then I need a positive 1x and a negative 2x. So that means this has to be positive and this has to be negative. All right, so that gives me negative 1. Also, positive 1 times negative 1 does give me negative 1, so that works out as well. And that's it. So we have just factored number 4. Okay, I'm going to do number 5 the same way. I see it's a trinomial, so I'm thinking, okay, if this factors at all, it's going to be a binomial times a binomial. 2x squared can only factor as 2x times x. 3 can only factor as 3 times 1. Now, in this case, the order does matter. If 3 and 1 doesn't work, then I will reverse these and try 1 and 3. Now, as I said before, inner plus outer must equal middle. Inner, I have 3x. Outer, I have 2x. I'm trying to get a middle of positive 7. This can only make 5, so this is not working. So the only other thing I can try is switching the 3 and the 1. So I'll try putting the 1 here and the 3 here. Now again, inner plus outer must equal middle. Inner I have 1x, outer I have 6x. Can I get 7 out of this? Sure, if I just let them both be positive, that'll make positive 7x. That means both of these would have to be positive. And I check one last thing. Positive 1 times positive 3 does give me positive 3, so this must be the answer. Okay, let's practice again on number 6. I see the trinomial, there's no common factor, so binomial times a binomial. A squared can only be a times a. 4 is either going to be 2 times 2 or 1 times 4. Okay, keeping an eye on the middle that involves a 3, I think the 1 times 4 is our best bet. So 1 times 4. So inner plus outer must equal middle. Inner, I have 1a. Outer, I have 4a. In order to get a negative 3, I would need a positive 1 and a negative 4. So positive 1 and a negative 4. Also, 1 times negative 4 is negative 4, so it works. So this will be the solution to number 6. All right. How about number 7? Listen, the first step of factoring is to factor out the GCF if there is one. Look for a GCF. That is always, always the first step of factoring. So this time there is a common factor. So 3 is the common factor. If I divide by 3, that's going to give me x squared minus 9. Now x squared minus 9 is the difference of 2 squares, so I have to keep going and factor more. X squared minus 9 factors as x plus 3 times x minus 3. And that is the answer to number 7. Okay, looking at number 8, I'm looking to see if there's a common factor. There is not. Now, this is not the difference of 2 squares either. So this is something else. This is the difference of 2 cubes. So keep the following in mind. Let me switch colors for a second. Actually, let's talk about perfect cubes. If I do 1 to the 3rd power, that's 1. 1 times 1 times 1. If I do 2 to the 3rd power, that's 8. 3 to the 3rd power is 27. 4 to the 3rd power is 64. And 5 to the 3rd power is 125. These are common enough that it's worth committing to memory. Let's do a few more though. So 6 to the 3rd power is 216. 7 to the 3rd power is 343. Okay, I'm getting a little dicey here. So taking a quick look at the calculator, let's see, let's use the table feature to find the rest. So I will just do x to the third power all right, and we'll look at the table. So second graph. All right, and I'll just scroll down a little bit. So here's the list, and you can see the ones that we already had. I went one too far. Okay, with 3 to the third power, 4 to the third power, 5 to the third power, 6 to the third power, 7 to the third power. So 8 to the third power is 512. And 9 to the third power is 729. And of course, 10 to the third power is 1,000. So looking back at problem number 8, notice the 8 and the 27 are both perfect cubes right on this list, 8 and 27. That is a clue to you that this is the difference of two cubes. So the way we factor the difference of two cubes, or the sum of two cubes, is this. First of all, memorize the fact that it's going to factor as a binomial times a trinomial. So leave yourself space for a binomial here and a trinomial here. The binomial is just going to be the cube root of each of these. Remember the 8 and the 27? Well, 8 is 2 cubed, and the cube root of 27 is 3. Remember that. So when I write my binomial, I'm going to have 2g minus 3. It's just the cube root of each of these. Now, this in the next set of parentheses, I will have my trinomial. Take these two terms and square each of them, and that's going to give you the first and last term. So if I take 2g and I square it, that's going to give me 4g squared. If I take 3, or even negative 3, and square it, either way I'm going to get positive 9. So that's the beginning and end. Now the middle term comes from multiplying these together. So if I do 2g times 3, that's going to be 6g. However, it'll be the opposite sign of this. So if this is positive, then if this is negative, then this will be positive. If this had been positive, then this would simply be negative. In fact, concerning the signs, sometimes we use the acronym SOAP to help us remember how the signs go. And SOAP stands for same, opposite, always positive. And that goes along with these three signs here. The first sign is always the same as the original problem. The second sign is always opposite from the original problem. And the third sign is always positive. So same, opposite, always positive. So, and that's it. We have factored number 8. Okay, number 9 is going to work exactly the same way. See 125 and 64. If we glance at the list, 125, 64, those are both perfect cubes. So this is the sum of two cubes. And so notice that this pattern works for addition and subtraction of two cubes, the sum and the difference. So we have just reviewed the fact that this is going to be a binomial. Let me just change colors because these are going to be close together. It's going to be a binomial times a trinomial. The binomial is just going to be the cube root of each of these. So the 125 and the 64, all right, the cube root of 125 is 5, the cube root of 64 is 4. So for that reason, I'm going to have 5 plus 4 r. Of course, the cube root of r to the third power is just r. So there's my binomial. If I square each of these, I will get my first and last term of the trinomial. So that's why here I will have 25, and here at the end I will have 16r squared. By the way, don't forget to square the r. Sometimes students will put just 16r. All right, you're doing 4r times 4r. This is 16r squared. And then finally, the middle term, you multiply these. So that's going to give us 20r. But it'll be minus. Remember, same, opposite, always positive. So this one will be minus 20r. And that's it. This is the answer to number 9. Okay. All right, number 10 is also going to be the sum of two cubes. Obviously, 729 is a perfect cube, all right? The cube root is 9. But a to the 9th power and b to the 6th power, these are also cubes because they are multiples of 3. So when I take the cube root of this, I'm just going to wind up dividing by 3. Same thing here. When I take the cube root of b to the 6th power, I'm just going to end up dividing by 3. So when I have the sum of two cubes, remember it will be a binomial times a trinomial. All right, so the cube root of 729 is 9. And the cube root of a to the 9th power, again, just divide by 3. So that's going to be a to the 3rd power. All right, the cube root of b to the 6th power is going to be b squared. All right, just divide by 3 there. So that's my binomial. Now, if I take each of these and I square them, that will give me my first and last term of the trinomial. So if I square this, that's going to give me 9a to the 6th power. All right, sorry. I meant that's going to give me 81a to the 6th power. We're thinking 9a to the 3rd power times 9a to the 3rd power. 9 times 9, of course, is 81. A to the 3rd power times a to the 3rd power is a to the 6th power, because you have to add those exponents here. Okay? And similarly, if I take b squared and I square that, that is going to give me b to the 4th power. For the middle term, you multiply these. So that's going to give me 9a cubed b squared. But the sign should be opposite. So I'm going to put minus 9a cubed b squared. All right, same, opposite, always positive. And so that's it. That's how you do number 10. Okay, number 11. Again, I'm seeing 4 terms. When I see 4 terms, the first thing I'm going to try is grouping. So I'm going to group these first 2 terms together, and I'll group the second 2 terms. And I'm going to factor out the GCF from both groups. So the greatest common factor here will be the x to the 3rd power. So if I factor out x to the 3rd power, that's going to leave behind x minus 3. And then here, the greatest common factor is, well, just looking at the 4 and the 12, the greatest common factor is 4. Because of the negative sign here, I'm going to look at it as a negative 4 that I'm factoring out. Okay, so if I factor out a negative 4, that's going to leave behind x minus 3. Okay, imagine doing the distributive property. Negative 4 times x would be negative 4x. Negative 4 times negative 3 would give you positive 12. So there you go. Okay, so we have factored out the GCF in each case. Notice how the parentheses are the same, all right, the same quantity, x minus 3. That's going to be necessary for the grouping method that we're using. Because the x minus 3 is itself a common factor, which must be factored out. So I'm going to take this x minus 3, and I'm going to put it out front. And that's going to leave behind the x to the third power and the minus 4. So that's going to leave behind x to the third power minus 4. Now I should look at this very carefully because I see the cube here. Now if 4 is a perfect cube, then I need to continue factoring using the difference of two cubes pattern that we have memorized. But of course 4 is not a perfect cube. So we're done. So this is the final answer.